Hey everybody, my name is Michael Levan. Thank you so much for joining me for this session on platform engineering. Now, we're going to do a couple of different things in this session. First, I'm going to talk a little bit about platform engineering. We'll show a little bit of PowerPoint. Hopefully it won't bore you too much. We're going to get through that. And then I'm going to share my screen, show VS Code, and dive into a little tool that I created just to kind of show some differences between interactions and interfaces and platform capabilities and all that fun stuff. So with that, let me go ahead and dive into the PowerPoint, and I hope that you enjoy. All right, so first things first, platform engineering, and really what it comes down to is it's your internal system as a product, all right? Now, what does that mean? Well, what that essentially means is platform engineering is nothing new. It kind of just has a name now. So throughout your DevOps journey, your SRE journey, your cloud journey, whatever, at a very high level, you've done one of two things, or both of these things. You've set up systems for applications to run on, and then you've set up or deployed those applications for external users like your customers and your clients to be able to use. You're doing the same thing in platform engineering. The key difference is your internal engineers and developers are your customers and clients, and that's why I like to think about it like it's your internal system as a product, all right? Now, platform engineering is nothing particularly new. I remember in 2016, 2017-ish, I was creating self-service portals for various engineers to be able to use, and I think my title at the time was like infrastructure engineer. All right, so we didn't have the fancy platform engineer title, but what we did have were the capabilities, and we were creating self-service capabilities. So it's your internal system as a product, right? Your internal teams are the customer. Now, I know that when you're talking about or thinking about or listening to platform engineering, a lot of people will say, like you're creating systems and platforms for developers, cognitive relief for the developers, separation of concern for the developers. But it's not just the developers. It could be the cybersecurity team. It could be the IT team. It could be the SRE team, the DevOps team. You could create these internal systems, productize them, and allow everybody to benefit. Right? And I like to split up platform engineering into three different pieces. So the platform interface, the platform capabilities, and the underlying platform. So the underlying platform could be anything from virtual machines to bare metal to like AWS ECS or Azure Container Apps. But typically what we're seeing in the cloud space right now is the underlying platform being Kubernetes, and it makes sense. Kubernetes is being iterated on a ton. There are several third-party tools that are being created for Kubernetes. And outside of running containers, we also now have the ability to run VMs with tools or platforms like kube-virt. All right, so the underlying platform, Kubernetes. Next up the list on the stack, you have your platform capabilities. And the platform capabilities are whoever is consuming this platform. So maybe you're creating it for a developer or you're creating it for another engineer. Whoever's using the platform needs certain capabilities. So maybe they need monitoring, maybe they need observability, maybe they want to create resources from Kubernetes outside of Kubernetes, so they would use something like Crossplane. Maybe they want Argo CD or another type of GitOps controller. Could really be anything, whatever type of platform capabilities they need, whatever they need to do on the platform. Just like, for example, when you log into the Azure portal or the AWS portal or whatever, there are capabilities, right? There are VMs and storage and et cetera, et cetera. So those are all platform capabilities. Azure in that case is, the platform. Well, I guess the servers are technically the platform, or Hyper-V rather is technically the platform, but you know what I mean. So you have the platform and then you got the platform capabilities. And then the next is the interface. All right. So for example, it could be any type of user interface, right? So that could be a command line interface or a CLI. It could be a GUI or a graphical user interface. You could give an API. You could even give an internal developer platform or IDP like Backstage or Port or some of the other ones that are coming out. There's also Radius and there's Kratix, and apologies if I'm not pronouncing that correctly, but KRATIX. Bunch of different projects coming out. So your platform interface is what you're giving the engineers or the developers or both. You're giving them a method to interact with the platform capabilities. So that interface could be anything that they want. And there's really no standard around that, because it could be a GUI based IDP or it could be a CLI. It really depends on what they want to use to interact with it. Same thing like when you interact with a platform or platform capabilities, how do you want to interact with it? All right, so the underlying platform, anything from Kubernetes to VMs, you're going to want to ensure that you still manage those underlying platforms like you would any other system. So you need to be able to monitor it. You need logs, you need traces, you need metrics, you need security around it, right? So you need proper RBAC, you need proper authentication, you need scanning, you need to be able to alert on and remediate CVEs, and then of course, maintenance and management on it, upgrades, updates, etc. And then the platform capabilities, again, whatever the developer wants, whatever the engineer wants, and then the platform interface, how you're actually hitting the capabilities. Now, there are like these platform interface and capability pieces that kind of tie together. So like, for example, Radius. Radius gives you the ability to create these recipes. The recipes are written in Bicep, and then you as a platform engineer create those recipes, and then you give those recipes to developers and engineers to use. So it's actually combining the interface and the capabilities. All right, so now what I want to do is I want to take a quick look at this tool that I created. All right, so this is actually a little something that I created just a couple days ago to kind of showcase some abilities around platform engineering, interfaces, and interactions. So I created a CLI called CAPI-PE, which is Capability Platform Engineering for short. Okay, and essentially this is what it does. And you can extend on this any which way you'd want to, but the available commands so far are Argo CD, Crossplane, and Flux. So essentially what happens is, let's say I just type Argo CD, that'll actually go and install Argo CD via Helm chart for me. Now, what does it kind of look like? Well, if I open up the code here, and I won't go too in depth just in case you don't know Go, but we'll keep it at a high level. So I import two primary libraries. The Cobra library. Cobra is a way in Go to create a CLI. And then the Helm chart libraries. So I create the CLI here, as we can see. Then this core code here from about lines 34 to 70, give or take, are to install the Helm chart. So the way that it actually knows how to do that is right here. I specify the Helm chart that I want to install, and then the Helm library or package in Go installs the Helm chart for me. So again, this is just a example, so to speak, of a certain interface. But let's say a developer came to me and said, hey Mike, I want a CLI to be able to interact with various capabilities in Kubernetes. This is just one way that we could do it. So with that, thank you so much for watching my session. Really do appreciate it, and I hope that you enjoy the rest of the sessions. Feel free to connect with me and follow me on LinkedIn at Michael Levan, Levan. Thank you so much.